Now let's take some example for odd functions. Now we know that what is odd function means f of minus x. If f of minus x equals to minus of f of x, then it is what? It is odd function. Okay. So let's take example. Example, say 1, y equals to f of x equals to say x cube. Okay. And another is, let's take another example, y equals to f of x equals to, what function is what? Sine of x, let's see. And 3, y equals to f of x equals to x. Let's see why it is odd functions. Now, let's substitute this. F of minus x is what? If I substitute over here, this becomes minus x raised to cube is what? Minus x cube. This is what? This is f of minus of f of x. Therefore, f of minus x become minus f of x. What is this? This is a condition for odd function, right? Therefore, it is an odd function. Let's take another example 1 prime. F of x equals to say x5 plus twice x cube. Let's check whether this function is odd functions. Now, you have to do is, you have to substitute x equals to what? Minus x in the given function. So, f of minus x equals to what? Minus x raised to 5 plus 2 minus x raised to cube. Since it is odd functions, so we will get what? Minus x minus 2x cube. Here x raised to 5 will come. So, if I take minus common, here I will get x raised to 5 minus minus plus minus minus 2x cube. This is what? This is my fx. So, I am getting what? F of minus x become minus f of x. Therefore, it is what? It is odd function. Now, let's see this, okay. Now, f of minus x equals to what? Sine of minus x. So, sine of minus x is what? Minus sine x. We have minus sine x. There, this is what? Minus sine x is what? F of x. Therefore, we have f of minus x become what? Minus f of x. Therefore, this is odd function. Similarly, over here, you can check f of x equals to what? X. When I substitute minus x, f of minus x is minus x. Therefore, this is what? Minus f of x. Therefore, f of minus x become minus of f of x. Therefore, it is what? It is odd function. Here also, this odd function. Now, let's visualize this. What is this? Okay. Now, let's try to visualize graphically. Let's plot here x, and here you can say y equals to x cube. When x equals to 0, 0 cube is what? 0. When x equals to 1, 1 cube is 1. Minus 1 is what? When x equals to minus 1, here I will get minus 1. When x equals to minus 2, 2 raised to cube is what? 8. Minus 2 is what? Minus 8. Let's draw this graph. Over here, okay. Here it's ranging, x is ranging, here 1 and 2, here minus 1 and minus 2, 1, 2, 3, 4, 5, 6, 7, 8, here 8. Here 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1, 1, 2, 3, 4, 5, 6, 7. Minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. When x equals to 0, 0, 0 satisfies over here, okay. When x equals to 0, y is 0 over here. Say this is x-axis, this is y-axis. Now, when x equals to 1, y is 1 over here. When x equals to minus 1, y is what? Y is also minus 1 over here. When x equals to minus 1 raised to cube is minus 1. When x equals to 2, when x equals to 2 over here, then y is 8. somewhere here like this. Okay, when x equals to minus 2 is 8 somewhere like this. Okay, here 8. So the graph goes like this, goes like this, like this. So for odd functions, okay, you can see here, this is what symmetrical at origin, either this way or this way. For these odd functions, so it is symmetrical at origin. Here we have x, o, y. When sine 0 is what? Let's make over here sine of x, here 0. Sine 0 is 0. Okay. Sine pi by 2 is, sine 90 is what? 1. Here you can say 0, pi by 2, pi, and so on. Here minus pi by 2, here minus pi. Here this is 1, let's say this is what? Minus 1. You know sine theta is oscillating at maximum 1 and minimum at minus 1. Okay, therefore, here we have sine 0 is 0, here we have, and then sine 90 degree is 1 over here. So it oscillates like this and goes like this. Okay, here like this, goes like this. So here we have 1 is maximum, here minus 1 is minimum. Okay, you can see this. Why I am drawing this? Because sin x is odd function, and you can see over here this is symmetrical at origin. Okay, therefore all odd functions is at symmetrical at origin. You can check over here. What about this? Y equals to fx. We have y equals to, here let's say x here y equals to, here f of x equals to x here. When x equals to 0, okay, this become, when x equals to 0, this becomes 0. When x equals to 1, this becomes 1. It becomes minus 1, minus 1, minus 2, minus 2, 2, 2. Okay. Now let's draw this graph over here. This here this x, y. 0, 0 satisfies over here. When x equals to 1, here 1, 2, here minus 1, minus 2. When x equals to 1, y is 1 over here. When x equals to minus 1, y is also minus 1 over here. When x equals to 2, 2 over here. When x equals to minus 2, minus 2 over here. Therefore, this graph is, it's a straight line. Here y equals to x, you can say f of x. It's a straight line, okay. It's a straight line. Even here also you can see it is odd function, okay, as well as this is symmetric about origin. Okay, this is symmetrical about origin.